let's get a little bit more specific. Somebody already mentioned when we did that 8-sided figure, somebody actually gave the actual word to that. What would we call that thing? An octagon. Okay, it was a stop sign would be a regular octagon, wouldn't it? Because all the sides are equal and all the angles are equal to each other. And it's 8-sided figure, we call it an octagon. Well, let's go through a list of different names for these. So, what if I had a 2-sided figure? Can I have a 2-sided polygon? No, because it wouldn't be closed up, would it? Yeah, it'd just be, well, make an angle. It could make an angle, right? But I couldn't close it up with just 2 sides, could I? I got to have how many? 3. So the least number of sides I can have to have a polygon would be 3 sides. So if I have, let's do this. Let's just put sides, and we'll put name. All right. So let's just go through this real quick. 3 would be what? A triangle. 4 sides. A lot of people say square. A lot of people say rectangle. Travis, what would you say?
Quadrilateral.
Right, quadrilateral. Quad, meaning 4, and then quadrilateral. Lateral meaning what? I said it already today. Side. Lateral means side. Okay, quad, 4 sides. So, in general, we call a 4-sided figure a quadrilateral. Okay, because not every 4-sided figure is a rectangle, is it? I could draw a 4-sided figure that doesn't have right angles, and it's not a rectangle, all right? Yep, or rhombus, and we'll talk about those. We have a whole chapter just on quadrilaterals, okay? We have a whole chapter just on triangles. In fact, we have a whole chapter just on right triangles. Whole entire chapter just on right triangles. Okay? Bet you can't wait.
How do you have right triangles?
5. 5 sides, right. Should be familiar to you, right? It's a big old building in Washington, D.C. Pentagon, all right? 6 would be
hexagon.
Right, hexagon. 6agon. 7. Yeah, I think they say heptagon. Where's their list? I've heard something else, but yeah, this book says heptagon. All right, 8. We already talked about that. What is that? Octagon. It's octagon. Who was in the news a few years ago? His mom, what'd they call her? The Octomom. You ever hear that? She had those 8 babies, like all at once, and anyway, there's a lot of controversy about it. What about 9? I bet you never heard of this one, unless you're looking at the you're looking at the chart, aren't you? Okay, yeah, what chart? Stop. Nonagon.
Where's the chart?
It's right up here in front of you. Number 10. 10 sides. Deca. Right, decagon. What, guys, right here, it needs to. Decagon, prefix deca. Where do you see deca? Oh, give me decade, right? 10 years. Anything else? Well, that would be a 1/10 of a meter, but 10 of something. Is there anything else? Decade, what else? Yeah, decimals, it's like a 1/10. It's deci is 10, yeah. What about a deca? Is there any other? I can't even think of anything.
Decameter.
Yeah, decameter, right, or deca, whatever. All right. 11. I've never ever used this word before. In fact, I got to look at the book to see what it is. Hendecagon. Never heard of this until I saw it in this book. Hen, and then decagon. Never heard of that. This is the last one. 12. I've heard of this. We call this dodecagon. Now weird. I guess this prefix must mean something. I never heard the prefix hen or do, but decagon. I don't know. You can look it up if you're really that interested in your English and vocabulary. Yes, Jasmine. Now, well, the basic ones. Yeah, you should know what these are. Okay, you should definitely know triangle, quadrilateral, pentagon, hexagon. Heptagon we probably don't use too much, but every once in a while they'll throw that in there. Do I have to write out SLDs? Do you really want me to do that? This is an honors class. I don't usually do that in my honors classes, but if it's constant like this, I'm going to have to. Alright? Just to get your attention. Octagon is definitely something we need to know. So, but after 10, I wouldn't worry about those too much. Alright? But yeah, know these words. I mean, they should be pretty familiar to you. Alright? Let's see what else they have. Equilateral, and sometimes they'll do this. What if you have n number of sides, which means it could be any number of sides. That's about all the actual formal names we give these things. We would just call it an n-gon. Or what if you had, like, I don't know, 73 sides? We're not going to memorize all kinds of crazy names, you know, forever and ever. We wouldn't be able to do that. So you would say it's a what? It's a 73 what? gon. Okay, you just say it's a 73gon. You'd hardly ever see that. You'd probably see it written as a polygon with 73 sides. All right. We will eventually, not in this chapter, but we will eventually get into a lot of these, and we're going to talk about the angles, about like an octagon, what are the degrees of the angles in an octagon, and all that good stuff. All right, let's go through this real quick here. I've got a, let's talk about perimeter real quick. We only got about a minute or two. Let's talk about perimeter. Actually, we've got about 3 or 4 minutes. Perimeter just means the distance around something. So they go through here and give you some kind of like formal equations and stuff. I'm not going to do that, especially with perimeter. I don't see any reason to learn any kind of formal equations for this. What I say is this. I use 2 words for perimeter, and I just say it's the distance
Between.
around, not between, but around. All right, which means the distance around that object. So watch, if I'm starting here and I want to find the perimeter of this, let's say it's a regular pentagon. This is a regular pentagon, all right, and that side was 5 right there. And I wanted to find the perimeter of this regular pentagon. If it's regular, what does it mean about all the sides? It means they're all the same. They're all equal to each other. Now, not every pentagon is regular, right? But in this case, it is. So, what's the, look, every side is 5 then, right? So what do? Just add them all up. Or, if they're all the same, just 5 times what? 5, right? I guess I could have made that a different number, but 5 times 5, and so what's the perimeter of this thing? It's 25. Let's say it's in meters, so it's 25 meters. All right? Easy enough. You with me on that? Yeah, so perimeter is easy. The only thing that's a little bit different on perimeter would be a circle. What's another name for a perimeter of a circle? Circumference, right. And we do have an equation that you do have to memorize for this. I'm not going to get into it too detailed, but you should already know this already. It's 2 pi r. What is the r?
Radius.
That's the radius, okay? That would be the r right there. Okay? So if the radius was 3, what's the perimeter of this? It's 2 times pi times what? 3, or 2 times 3 is 6. 6 pi. I would actually let you leave it like that if you wanted to. Or what would you put in your calculator for this? 3.14. Okay? There's a couple things we may not have quite finished, but on page 58 there's some examples. So I would look at those before you start. Of course you do. Before you start on the homework. So let me write down your assignment, and then you can go to chapel. Okay, here we go. So it's section 1-6, obviously, and it's pages 61 and 62, and we're doing 11 to 32. 11 to 32. Make sure that you read over those examples. I mean, we started on this a little bit. It's not really that difficult. I think you can handle that. We didn't talk about area. That is covered on there, so read the examples on area, and I think you should be fine. All right. Have a good chapel.